Okay, so now we're going to take a look at the parent graph for the tangent function, and tangent is the quotient identity sine over cosine, or y over x on the unit circle. So let's go ahead and fill in our first quadrant reference angle tangents. So 0 divided by 1 is a tangent of 0. 1 divided by 0 is undefined, so our quadrantals are 0 and undefined. At pi over 4, the y and the x are the same, and a number divided by itself is 1. And if you remember our shortcut for pi over 3, the denominator is 3. That reminds us that root 3 is the tangent. And then pi over 6 is smaller than pi over 3, so that's the one that gets the root 3 over 3. That was the shortcut that we talked about, our memory device for remembering your tangents in quadrant 1. So if we have a tangent of pi over 4, that's going to be a positive 1. Pi over 2 is undefined. Then 3 pi over 4, tangent, if you remember, all students take calculus, tangent is negative in quadrant 2, so that's going to be a negative 1. Then at pi, we are quadrantal along the negative x-axis. 0 divided by negative 1 is 0. 5 pi over 4 is quadrant 3. Tangent is positive in quadrant 3. That's a positive 1. 3 pi over 2 is quadrantal along the negative y-axis. Negative 1 divided by 0 is undefined. So we're going to have vertical asymptotes at pi over 2 and 3 pi over 2, just like for the secant function. Then at 7 pi over 4, we're in quadrant 4, where tangent is negative, so that's a negative 1. And at 2 pi, positive x-axis, tangent there is 0. So let's go ahead and sketch these points on the graph, and we'll start with our vertical asymptote here at pi over 2. And another vertical asymptote at 3 pi over 2. 3 pi over 2 minus pi over 2 is 2 pi over 2, which is pi. So our asymptotes are pi units apart. That makes them located at x equals pi over 2 plus or minus k times pi, where k is an element of the integers. And so we can sketch those asymptotes, counting back 4 check marks for pi units. 1, 2, 3, 4. So negative pi over 2 has a vertical asymptote. Then 1, 2, 3, 4. Negative 3 pi over 2 has a vertical asymptote. So at pi over 4, we have a point here at positive 1. 3 pi over 4, we're at negative 1. Then at pi, we have a 0. 5 pi over 4 is a positive 1. 7 pi over 4 is negative 1. 2 pi is a 0. And if you recall, when you're going through or between asymptotes, you approach the asymptotes but don't touch or cross them. And then we need to wiggle our way through these guide points here. And that's a little messy, but we got the idea. So we're making a wave through these anchor points. So following that pattern now in reverse, we can fill in our zeros and our negative 1 and positive 1 guide points. And that would be 2 cycles of our tangent graph. A bit messy, but we got the idea. So the description of this shape, these are vertical wiggles, sort of like our cubic function shape, only they're not cubic because remember cubic functions go on to positive and negative infinity to the left and the right. These are blocked off by asymptotes, so they're not going to extend past those vertical asymptotes. We do have a y-intercept for this function at the origin, which is the coordinate 0, 0. We have real zeros as well. They are pi units apart, and our first non-negative 0 is at the origin. So this would be x is equal to plus or minus k times pi, where k is an element of the integers. Hey, the period has changed. All of our parent graphs for the previous trig functions, sine, cosine, secant, cosecant, those all had a period of 2 pi. Now this pattern repeats every pi units. So our period here is pi instead of 2 pi. There are no relative or absolute extrema in the tangent graph, so extrema is a none. Our domain is all real numbers except where x is undefined, which is at those vertical asymptotes. So x cannot be equal to pi over 2 plus or minus k pi, where k is an element of the integers. And then the range, notice between the asymptotes, these ends are headed up and down to positive and negative infinity. So our range is fully unbounded interval negative infinity to positive infinity. So looking at our applet to construct the tangent function, here as we go through quadrant 1, we see that one side, the right side of that wiggle, then there's our vertical asymptote at 90 degrees or pi over 2 radians. Now in quadrant 2, we see the curve coming up, right, along that vertical asymptote, approaching this real 0 at pi or 180 degrees. Now it's going to wiggle through that 0 into quadrant 3. Now we're bending again back up towards positive infinity. We can't cross this vertical asymptote at 270 degrees or 3 pi over 2. So now we're approaching the fourth quadrant now from 3 pi over 2 to 2 pi, and here comes another piece of that wiggle, and we're back to 0 or 360 in degrees 2 pi radians.